Hello, in this video, I'd like to cover a volumetric analysis or just simple titration. And I'd like us to begin with the definition. It is the process of determining a known concentration of a reaction from a known concentration and volume of another. So in simple terms, I may be having a reaction, say A plus B to form C and D. In such a case, the concentration of A can be known, the volume of A can be known, and the concentration of B cannot be known, and the volume we are given. So in such a case, at some point in time, you may be asked to get the concentration of B given its volume, and it is reacting with A, which has a concentration and the volume. Now, when you talk about volumetric analysis, you may be given one substance or one reaction, not really reaction, but one substance that has a concentration and a volume, and you're supposed to determine either the concentration or the volume of another. Now, there is one note that I'd like us to know is that reactions takes place in simple mole ratio of reactants and products. What do I mean by that? Assuming that I have a reaction A, B to form C and D, in simple terms I can say 1 mole of A from here, 1 mole of A reacts with 1 mole of B to form 1 mole of C and 1 mole of D. Or rather, if I have 2 moles of A reacting with 1 mole of B, it can form 2 moles of C plus 3 moles of D. Now, these are the simple mole ratios to which these reactions normally occur or undergo. The mole ratios, we find them from simple stoichiometric balancing of equations. Now, I have a simple question that I'd like us to handle. I hope you can clearly read it. You can pause the video and read with me. Calculate the molarity of M carbonate of 5.0 cubic centimeter of M carbonate. So we are told if 5.0 cubic centimeter of M carbonate reacts with 25 cubic centimeter of 0.5 molar HCl, and we're given the simple arithmetic there. Now, if we are given M carbonate, what does it stand for? It is just a metal carbonate, and a metal, in this case, the valency of the metal is 2. So if I were to write the formula of the metal carbonate, the valency of the metal is 2, carbonate is 2. That is why it leads back to formation of this kind of a formula. Now, when you're given such a question, the first thing you're supposed to do is to write the equation for the reaction. And how do I write the equation for the reaction? Now, I'm having two things reacting. I am having a simple metal carbonate, which is a solid, reacts with HCl, which is an aqueous solution. Now, when a metal carbonate reacts with an acid, it forms three things: salt, water, and carbon 4 oxide. And in this case, I'll form the M chloride aqueous plus carbon 4 oxide gas plus water molecules being produced. Now, from there, I can balance the equation for the reaction. So if I put 2 here, the whole equation is balanced. Now, what else am I given from the equation? Calculate the molarity of M carbonate if 5.0 cubic centimeter of M carbonate, 5.0 cubic centimeter of M carbonate reacts with 25.0 cubic centimeter of 0.5 molar HCl. Now, that is one thing that I normally advise students to do. Always write whatever you've been given below the substances or the compounds that we're having in the question. So we are asked to calculate the molarity of M carbonate. And what do I mean by molarity? It's just the number of moles of a solute in 1,000 cubic centimeter of a solution. So it means that I must get the number of moles of M carbonate and I equate it to 1,000 if that number of moles is in 0.5 cubic centimeters. Now, if I have the concentration of HCl and the volume of HCl, I can calculate the number of moles of HCl contained in 25.0 cubic centimeter. And how do I calculate that one? Whenever you're told 0.5 m or molar, it means that 1,000 cubic centimeter of a solution contains 0.5 moles in terms of solute concentration of HCl. How about 25.0 cubic centimeter that we are given? What number of moles will it contain? It will contain 25.0 cubic centimeter times 0.5 moles divided by 1,000 cubic centimeter. I just do simple crossing, just like in primary. So when I cross them, I will get, when I punch that in my calculator, I'll get 0.0125 moles of HCl contained in 25 cubic centimeter. Now, if I have the number of moles of HCl, how do I get the number of moles of M carbonate? Remember, I said that reactions take place in simple mole ratios of reactants and products. Therefore, if I take the mole ratio of M carbonate to 2HCl from the stoichiometric equation, 1 mole of M carbonate reacts with 2 moles of HCl. Therefore, the mole ratio will be 1 to 2. It therefore means that this 2 for HCl represents 0.0125 moles. How about this 1 mole of M carbonate? What will it represent? 0.0125 moles times 1 divided by 2 from this 2. And when I punch that one in my calculator, I will have 0.00625 moles. Now, these are the number of moles of M carbonate, but keep it in mind, this number of moles of M carbonate are contained in 5.0 cubic centimeter. But what was the question? We were asked to calculate the molarity of M carbonate. And what did I say about molarity? It is just the number of moles of a substance in 1,000 cubic centimeter of a solution. In this case, I'll ask myself this simple question. If 5.0 cubic centimeter, this one, contains 0.00625 moles. How about in 1,000 cubic centimeter of a solution? It will contain 1,000 cubic centimeter times 0.00625 moles divided by 5.0 cubic centimeter. Now, when I calculate that one in my calculator, I will have 1.25 moles, or molar, not really moles, but molar. Or I can say 1.25 moles per liter, or I can say 1.25 moles per decimeter cube. So that is how simply I handle such a question when I'm asked. Now, I'd like us to do the second question, and I hope you can clearly read it together with me. We can read it together. 2.0 cubic centimeter of 0.5 molar HCl react with 0.1 molar of M carbonate, but remember it is M2 carbonate. Calculate the volume of 0.1 molar of M carbonate. Now, how do I do such a question? Remember, the first thing I said is to write the equation for the reaction. Now, what do I have, or rather, what am I given? I have M carbonate, and M carbonate is M2CO3, that is the solid carbonate reacting or diluted in HCl, that is the acid. It will form salt, water, and carbon oxide. Now, what is the valency of M? In this case, the valency of M is 1. That is why it crossed to have 2. If I were to write it initially, M and CO3, CO3 is 2, M is 1. And that is why when it crossed, it leads back to such a thing. And I hope now you understand how it came back to M2CO3. Now, when I write the equation for the reaction, I'll have MCl as the salt, aqueous, plus carbon 4 oxide gas plus water. Now, if I try to balance it, I'll have 2 moles of the HCl reacting with 2 moles of the reacting with 1 mole of the M carbonate to form 2 moles of the metal chloride and 1 mole of carbon 4 oxide and 1 mole of water being released. What am I told about these things? I'm told that 2.0 cubic centimeter of 0.5 molar HCl react with 0.1 molar metal carbonate. I'm supposed to calculate the volume of the metal carbonate. And now, what do I need to do first? I need to get the number of moles of HCl contained in 2.0 cubic centimeter. And how do I do that? Remember, I said that whenever I given 0.5 m, 0.1 m, it means that that is the number of moles in 1,000 cubic centimeter. So I'll say if in 1,000 cubic centimeter, I have 0.5 moles of HCl from the molarity. How about in 2.0 cubic centimeter? The answer will be 2.0 cubic centimeter times 0.5 moles divided by 1,000 cubic centimeter, and that one will give me 0.001 moles. So that will be the number of moles of HCl. From there, how do I get the number of moles of M carbonate? I use the simple mole ratio. It means that the M carbonate to HCl, the mole ratio is 1 to 2. 1 mole of M carbonate reacts with 2 moles of HCl. So this 2 represents the number of moles of HCl which we were given 0.001 moles. How about 1? So it will be 1 times 0.001 moles divided by 2. So when I divide it by 2 in my calculator, I'll have 0.0005 moles. So these are the number of moles of M carbonate. And we are asked the volume of M carbonate that was used or that reacted. How do I get that? Keep it in mind, whenever I given 0.1 molar, it means that 1,000 cubic centimeter, or rather 0.1 moles contains or is contained in 1,000 cubic centimeter of a solution. How about 0.0005 moles? What will it contain? It will be contained in 0.0005 moles times 1,000 cubic centimeter. Everything you divide by 0.1 moles. And if you do that, these moles will cancel. I'll only have the volume, and if you punch that in the calculator, I'll have 5.0 cubic centimeter. So that will be the volume of the metal carbonate that we used if in case we dissolved it in a solution first before doing the reaction. So it means that in such a case, this will be in aqueous. So this is how simply we handle question number 2. Now let's try to do another question, number 3. Now, we have question number 3. How do I handle question number 3? What am I told? I am told that 5 cubic centimeter of 0.1 molar sodium iodide react with 0.1 molar of lead to nitrate. Calculate first the volume of lead nitrate and secondly the mass of lead iodide that is formed. How do I approach such a question? The first thing I need to do is I write the equation for the reaction. What am I told? I'm told a very simple thing, that sodium iodide reacts with lead nitrate, and those are the formulas. Now, when the reaction takes place, there is something called exchange of ions. Sodium takes the nitrate to form sodium nitrate, and then lead takes the iodide to form an insoluble lead iodide, which is a precipitate. And when I try to balance the equation, I'll have 2 moles of sodium iodide reacting with 1 mole of lead nitrate to form 2 moles of sodium nitrate and 1 mole of lead iodide. So that is how simply we write the equation for the reaction. Now, under these substances that I am given, what do I have? 5.0 cubic centimeter of 0.1 molar sodium iodide, 5.0 cubic centimeter of 0.1 molar sodium iodide reacts with 0.1 molar lead nitrate. Calculate the volume of lead nitrate. That is very simple. How do I do it? I'll say if in 1,000 cubic centimeter I have 0.1 moles of sodium iodide. How about in 5.0 cubic centimeter? How many moles will I have? 5.0 cubic centimeter times 0.1 moles divided by 1,000 cubic centimeter. The cubic centimeters will cancel, and when I feed that one in the calculator, I will have 0.0005 moles. So that will be the number of moles of sodium iodide. If I have that number of moles, how do I get the number of moles of lead nitrate? It is a very simple thing. I just get the moles from mole ratio. So there is a reacting mole ratio between sodium iodide and lead nitrate, and the mole ratio from the balancing, it will be 2 to 1. Therefore, 2 represents 0.0005 moles. How about 1? 1 will represent 0.0005 moles times 1 divided by 2. And when I punch that one in my calculator, I will have 0.00025 moles. So that is the number of moles of sodium iodide. Not really sodium iodide, but lead nitrate, because I calculated it from the mole ratio. So how do I get the number of the volume of lead nitrate? From here, 0.1 molar, it means that 0.1 moles of lead nitrate is contained in 1,000 cubic centimeter. How about 0.00025 moles? What will be the volume of the solvent? 0.00025 times 1,000 cubic centimeter. These are moles. Divide by everything, 0.1 moles. And when I do that in my calculator, I'll have simply 0. So when I have this one in the calculator, 0.0025 times 1,000 divided by 0.5, that one will give me 2.5 cubic centimeter. So this will be the volume of lead nitrate that will be produced, that will be used, sorry. Now, we have the final simple question that we are asked. Calculate the mass of lead iodide that is formed. And how do I calculate the mass of lead iodide? Remember, in my previous video, I talked about a triangle. And in this triangle, I said that if I am given the number of moles of anything, I'll get it from mass divided by the relative molecular mass. It means that if I want to get the mass of anything, I'll take moles times relative molecular mass. Now, I don't have the relative molecular mass of lead iodide. I don't have the number of moles of lead iodide. So how do I calculate them? The number of moles of lead iodide, we said that in this reaction, 1 mole of lead nitrate reacts to form 1 mole of lead iodide. It means that the mole ratio between lead nitrate to lead iodide is 1 to 1. It means that if this is the number of moles of lead nitrate, it therefore means that the same number of moles will be the same number of moles of lead iodide. Therefore, lead iodide will be equivalent to 0.00025 moles. So that is the number of moles of lead iodide. Now, how do I calculate the molar mass of lead iodide? From this thing, we are told that the molar mass of lead is 207. Molar mass of iodide is 126. So from there, the molar mass will be lead itself is 207 gram per mole, plus iodine itself is 126, but they are 2. I multiply by 2, and the answer will be 459 gram per mole. And now, how do I get the mass? Mass will be equal to moles times molar mass, and the number of moles is 0.00025 moles times 495 gram per mole. The mole will cancel, and if I punch that one in my calculator, I will have 0.11475 gram. So that is how simply we do such questions. I have a final question here that I'd like students to try to do that question, and later on you can leave a comment. So that is what I have today, and may God bless you. See you in the next video. Bye. Don't forget to subscribe.